Okay, so if I'm teaching you something new, okay, I'll be having it up on the smartboard just like this, okay? And the first slide will always be lesson number and title that matches what's in the notes package. Okay, so if you have the notes package, you'll see the same lesson number and title so that you can kind of match them up, because they're going to look a little different on the board than obviously they look in the notes package, so I can save trees. Okay? What you will also see in both the notes package as well as on the board are the key points for that particular lesson. Okay? Good idea to make a note of those so you know when you're studying, these are the things I really have to know out of this unit. This is what's definitely going to be on a quiz or a unit exam. Okay, so for this particular lesson, okay, we're going to look at how the theories of the structure of the atom were developed. Okay, I mean, you're going to need to know a couple of names of people, okay, but more we want to know about the process. Okay, why did you think the atom looked like this, and then we thought it looked like that, and then something else and something else. Okay, and obviously learn the parts of the atom and their characteristics. That part's probably going to be reviewed. You probably already know about protons, neutrons, and electrons, and their charges, and all of that stuff. Okay. Now, because you have access to the notes package, I wouldn't worry about trying to write absolutely everything down. I mean, if you want to, if that's your learning style, go for it. Pen's probably going to be smoking by the end of class, though, because I'm going to go fairly fast. That's why I make the package available to you, and so that you don't necessarily have to write everything. If I write something on the board, it's definitely important. Okay, if I'm adding to what's here, you should definitely add that as well. Okay, any questions so far? Okay, please don't be afraid to ask questions, okay? I love questions, so please ask, okay? Okay, so before chemistry was a true science, okay, we were still using the physical and chemical properties of materials to help us out, okay? And then there was a group of people in the Middle Ages who, you know, kind of toyed around with the physical and chemical properties of matter, okay? Basically trying to get rich and do things that we now know are impossible, like turn lead into gold and make an elixir of life that would make you live forever, but most of which did the opposite and made you drop dead very quickly. Okay? Things like that. Those were the alchemists. Okay? They actually contributed a fair amount to our knowledge of how matter behaves. Okay? So stuff on this slide, yeah, not that important. Okay? Just kind of background information. This is not likely to be anything that would be on a quiz or a test. It's just background. Okay? So if I go fast, it's probably because you probably didn't need to write anything from that slide. Okay? It's just so you don't panic. If I've moved on and you haven't had a chance to write everything on the board, there's probably a reason for that. Okay? All right. Now, this slide, I'd say some of the stuff on here is important because we're going to talk about the first atomist. Okay? The first person who came up with the idea that all matter could be composed of tiny, indivisible particles. Okay? So believe it or not, we've had this idea around for 2 millennia already. Okay? It just wasn't accepted. Right? So the first atomist, okay, was Democritus. Okay? So I would say probably Democritus, that's probably a name you'll want to remember. Okay? He was, after all, the first person to have that idea. Okay? Democritus was a thinker in Greece, which was like the best job you could have in ancient Greece, was to be a thinker. You would sit in the Parthenon and people would like fan you with a big palm frond and feed you grapes all day, and all you had to do was think of stuff. Plato was a thinker, Aristotle was a thinker, okay? All of those kind of famous guys. So when Democritus came up with this idea, it didn't go over well, okay? Because the Greeks already believed that all matter was made of 4 elements. Okay, the four elements: earth, air, fire, and water. Okay, and this idea made tons of sense to them. Okay, it's why Democritus' idea was basically thrown out. Okay, having everything made of these four materials made a ton of sense because it was real to them. Okay, as an example, steam was some parts water, some parts fire, and some parts air. Okay, it made sense. You added fire to water, and it turned into air. So it made sense that steam would be some parts of all three. They essentially knew, okay, it's this much of fire, and it's this much of water, and it's this much of air, okay? And they kind of had this, almost like a periodic table of their own, okay? Molten lava, something the Greeks were familiar with, okay? That would have been some parts earth, a lot of parts of fire, okay? And some parts water, because it would flow like water, okay? Now, yes, sure, there's water in all molten rock, but not a lot. Okay, but it flowed like water, so it was something that made sense to them. Okay, they could basically explain every material that they were familiar with in terms of how much earth, air, fire, and water was in it. Okay, it made a lot of sense to them, it was very practical. Okay, so they accepted it. So that day when Democritus was like, hey, you know what, I bet all materials are made of these tiny little particles that you can't see. Okay, people probably looked at the person who was supposed to be fanning him with the palm frond and said, you're letting that guy get too hot. Okay, he's starting to spout nonsense because his brain's getting overheated. Okay, because that doesn't make sense to anybody. You're telling me stuff's made of things I can't see? I don't like that idea. Okay, now, ends up, he was absolutely right. Okay, but it just wasn't accepted because he couldn't prove it, and it didn't make sense to the people at the time. Okay. All right, so I would say from that slide, know the four elements: earth, air, fire, and water. Okay, know Democritus, and know that he came up with the idea for the atom. An easy way to summarize that slide. Now, wasn't all bad for Democritus. Just because people didn't like his atom idea doesn't mean he didn't come up with other good things. Something that sounds like his name, that we rather enjoy. Democracy. He went more into the arts and humanities than the sciences after his debacle with atoms. Okay, but coming up with democracy is not a bad thing. Okay, anybody need that slide anymore? All right, then people kind of forgot about Democritus and atoms, and the Middle Ages came along, and this is like Da Vinci's lab, Leonardo da Vinci's lab, okay? An alchemist would have had a lab like this. He would have had mortar and pestles and all kinds of, flasks and beakers and tubes and all kinds of funky looking containers and apparatus in there. And they would have gone about their days mixing things together to see what they could make. Okay? The reason they weren't overly successful is because they didn't understand the nature of matter. And that includes that it's made of tiny, indivisible particles. Okay? They were trying to turn lead, okay, which is an element, into gold, which is another element. Okay? Can you turn one element into another? No. An element, that atom is the smallest form of that thing. Okay? I can't change the structure of an atom using a chemical reaction. Okay? And that's what they were trying to do, and it's why they weren't successful. Why did they think that they could do that? Because they thought they already were. When you would mix two things together, your end products would have very different properties. And it would look like you turned these things into something else. So there was no reason for them to think they couldn't turn lead into gold. Okay? They just didn't understand that that was very different than mixing vinegar and baking soda together and getting a gas produced. Okay? They just didn't understand kind of what was going on when they did that. Okay? But at the same time, they did learn a lot about the behavior of matter. Okay? So that's really all you need to know about the alchemists. Okay? They were trying to do some things that were not possible because they lacked the understanding, okay, of what they were trying to do. Okay, so alchemy became chemistry eventually. Okay? Thanks to these two guys who I'll probably never ask you about. Okay? And that would be Antoine Lavoisier and Roger Bacon. They developed the scientific method. Okay? Scientific method is what took trial and error, anecdotal evidence gathering and things like that into legitimate science. Okay? They're the people who came up with how you write a lab report. Right? You start with a problem, and then you have a hypothesis, and then you have a procedure that you follow, and that procedure is controlled and repeatable, and then there's analysis and a conclusion, and that was their thing. Okay? They turned alchemy, which was, I'm going to mix these two things together today and hope I don't blow up, okay, into here's what I'm investigating, here's what I'm going to do to test it, here's how I'm going to make sure that I'm doing that in a controlled manner, okay, changing it into something respectable. Okay, so that's what paved the way for modern chemistry. Okay, again, I'm not going to ask you about Lavoisier and Bacon, okay, they're just the guys that turned alchemy into chemistry. Okay, now, the idea of the atom. Okay, so you can see there that there's some bold-faced, underlined wording. That's the important stuff. Okay? An atom is the smallest particle of an element, okay, that still retains the properties of that element. Okay, meaning its boiling point, its melting point, its color, its texture, luster, okay, all those physical properties. Okay, so the idea of the atom came back as people started doing legitimate chemical, or chemistry, I should say. Started doing legitimate chemistry. Okay, controlled experiments, okay, and making good observations on the behavior of matter. Okay, it was starting to look like, okay, when these two things go together, it seems like there's pieces of them that are moving around in predictable ways. Okay, and that couldn't be explained if everything was only made of four things. Right? It could only be explained if things were made out of tiny particles, okay, that couldn't be changed but could move around. Okay. Now, can you cut an atom? Like if you're at home, making soup, chopping carrots on the cutting board, do you have to worry about causing a nuclear explosion? Okay, why not? Why do you not have to worry about that? I mean, you're cutting stuff, you're cutting matter. How thick is your knife? Like it looks thin on the sharp edge, right? That's still like thousands, maybe even millions of atoms thick. Okay, atoms are really small. Okay, if you were looking like at a microscopic level at what you're doing when you're cutting something, it would look like you're like mashing things. Okay, when you slice a carrot with a really sharp knife, okay, if you're looking at that at an atomic level, it looks like you're just smashing through something. Okay, because that sharp edge looks blunt. Okay, and it's atoms and atoms thick. All right, so you never have to worry about splitting an atom when you're cutting something. Okay, splitting an atom requires using particles that are smaller than an atom and shooting them at that atom. Okay, and hoping that you'll break it. Okay, that's how nuclear power, nuclear bombs, things like that work. All right, so anyone need that slide anymore? Okay, so atoms, the smallest unit of matter for each element. Now, if that's the case, and all elements or all atoms are made of the same things, right? All atoms are made of protons, neutrons, and electrons. How do we get all these different materials? If everything's made of protons, neutrons, and electrons, why is an atom of carbon different from an atom of lead?
It's just different amounts of electrons and protons.
Yeah, it's the amounts of those things. In particular, it's the amount of protons. Okay? The amount of protons in an atom is what determines the properties of that element. okay? And that's a number we can get off the periodic table, okay? We're looking at carbon. Carbon has 6 protons in its nucleus, whereas lead has 82 protons in its nucleus. Lead atoms are bigger, okay? That's why if I had like, let's say a 10 centimeter by 10 centimeter by 10 centimeter cube of carbon and exactly the same size cube of lead, which one would be heavier? The lead, okay? I've got the same amount of matter in there, but every atom of lead is way bigger and way heavier, okay? So if I had the same number of atoms in each one of those blocks, okay, the lead would be way heavier because all of its atoms have way more stuff in them, okay? And that's why it has different properties, okay? The number of protons in an atom is what determines the properties of that material, okay? Okay, so here's probably the most important person when it comes to atomic theory, okay? I'm going to stop talking for a minute here, okay? And I want you to write down John Dalton's atomic theory. That's those 4 points, okay? His atomic theory has 4 points. So I'm going to give you a few minutes to write those down, and then we're going to talk about them. Okay, if you're not done writing, just finish up. I'm just going to start talking about these points here. Okay, so John Dalton, okay, was a chemist. He performed a lot of, reactions, experiments with chemical reactions, mixing things together, okay? And the patterns he was seeing were indicating to him that when he mixed these things together, they might have been made of smaller parts, okay? So for example, if he mixed like hydrochloric acid, okay, with like sodium hydroxide, let's say, okay? He knew that when he was done, he ended up with a solution that was neutral, okay? He took a strong acid and a strong base and mixed them together, and when it was done, he had something neutral. Well, what's something that's commonly neutral? Water, okay? One of the things he ended up with at the end was water. But he also noticed that that water was salty. Okay, now maybe, I don't know if he tasted it, that's not good like safety practices or anything like that. Okay, but he knew at the end he didn't have what he started with in terms of the actual materials, but he had the same elements. Okay, if you notice in that chemical reaction, I start out with hydrogen, chlorine, sodium, oxygen, and more hydrogen. And when I'm done, I still have hydrogen, oxygen, sodium, and chlorine. I haven't come up with any new elements. I've got new materials, I've got new compounds, because what's happened is the atoms have rearranged. Okay, the elements have moved around. But I didn't change lead into gold, okay, or anything like that. I still have the same elements that I started with. Okay? That's what led him to believe that maybe Democritus, 2,000 years ago before him, okay, was onto the right idea. Okay? And that there was actually these small indivisible particles, okay, that could move around and behave that way. Okay? So his experiments led him to develop this theory of the behavior of matter. Okay? That all elements are composed of tiny, indivisible, okay, not invisible, okay? They're indivisible. That means you can't split them, right? Something we now know maybe isn't 100% true, okay? Particles called atoms, okay? The second point was that all atoms of the same element are identical, okay? So every atom of carbon is going to have 6 protons, and it's going to have 6 electrons. Okay, and almost all carbon atoms also have 6 neutrons. Okay, there's the odd case where you might have one with 8. Okay, but they're pretty rare. There's something we call isotopes. Okay, so atoms of the same element are identical. Well, that's why, okay, all carbon atoms have the same properties. Okay, and of course then that would mean that the atoms of one element are different from the atoms of another. So carbon atoms look different than lead atoms do. Okay, everybody all right with that idea? Kind of talked about that before. Okay, his third point, atoms of different elements can combine in simple whole number ratios to form compounds. The whole numbers part is important. So maybe underline that part. Okay? What that means is you can't have half or 3/4 of an atom in a compound. Okay? They're always going to be whole numbers. So for example, hydrogen chloride is 1 hydrogen to 1 chlorine. Okay? Water is 2 hydrogens to 1 oxygen. Okay? I wouldn't write water like this. HO 1/2. Okay? I mean, the ratio is still 2 to 1, but that means I have half an oxygen atom. Well, half an oxygen atom would be a beryllium atom. Right? Going from 8 to 4, it's not the same thing. Okay? That's what he means by whole number ratios. Okay? Is you never have a fraction of an atom. Okay? And then the fourth one was kind of the one that put to rest the ideas of alchemy. Okay, this idea of I can turn lead into gold. Okay? Dalton's fourth point tells us unequivocally what can happen in a chemical reaction. And it states you can't change one element into another element. Okay? In a chemical reaction, all that can happen is atoms can be separated. They could be joined. Or they could be rearranged. Okay? The reaction I wrote for you is a rearrangement. Okay? They're all still there, but they have new partners on the other side. Okay? You could also have a reaction that looks like this. I could put lithium and chlorine together. That would be joining atoms. Okay? Obviously I would need a 2 here as well. Okay? So that would be the joining of 2 atoms. I could do this. Whoop, sorry, I wrote the wrong way. It's supposed to go the other way. Okay, I could separate water, so 2 waters, into hydrogen and oxygen. So there's joining, there's separating, and the other reaction would be rearranging. In any of these reactions, do I produce new elements? No. I always have the same things on both sides of the arrow. I'm not making anything new. Okay? I might make something that looks new, but it's made of the same things that I started with. That was Dalton. That was kind of the key part of Dalton's atomic theory. Okay? He put to rest this idea that you can do magic, okay, with chemistry. Right? He said there are rules that govern the behavior of matter when it's reacting and doing stuff. Okay? Everybody with me there? Okay. That's kind of a good stopping point for today. I don't usually stop before the end of class, but that's kind of a good stopping point. You've been drinking from a fire hose all class, so we'll kind of stop and give you a little break here. Okay. Does anyone need help finding their period 2 class? How's that? Maybe? Okay, let me know if you do. And I had 2 people we need to do the email addresses for, right? Okay. Okay, if you needed help with your email, pop on up here. Okay, sorry, your name was? What was the last name?
My afternoons, I have foods and then construction. We got 3 hours. Do we know what
Wow, I wrote the wrong password down. I have to bring it back to the Did you know No? I'm trying, right? Alright, so that's in the bottom.
We're the same teacher.
Okay, Rob, sorry, I wrote down your Power School username. Sorry, what's the last
He was like dying of food but I was stuck in traffic all the way down like back to your house. So I got here like that's okay. And I guess it happened like every morning because they need more than one road.
Who do you have? Go out this door, that's the chem lab. If you turn left, it'll be the next door past it. Okay, yeah.
Not bad.
Hey! Where your next class is? Okay, who do you have? Oh, you don't know that even. Okay, let's have it. Sorry, what was the name again? Your next is math with Mr. J. Okay, so you're going to go all the way to the end of this hallway. Turn right. Go all the way to the end of that hallway. He's the last room on the left. Okay, so all the way to the end. Mr. J.O. Yeah. Oh, okay. And you're getting email? You did not get the email. Okay. Do you know your Redeemer email? The @Isidore.Redeemer, that one? No? Just sit anywhere for now, guys. I'll move everybody in a minute.
Ken lives in alternating with computers and business and then English. I don't know how you manage to get all the math-based stuff. So it doesn't on the plus side though, I go there to be a small class, which is smaller.
Okay, so should put some who's your teacher? Okay, I think go to the gym. The gym's closed. But else, I think her and Mr. Hassett, Mr. Ale, or any people in front of the somewhere else right there. She's a short lady. Oh, okay. Yeah, just put it in 36. Yeah. Jail? I have no idea. Okay. That I'll need to know. Yeah, just sit wherever. I'm going to move people around. Just sit wherever for now. What was the name, sir? What's the last one? Oh, that's why I can't look you up. Oh, okay, yeah, but do you have your timetable? Okay, but I don't know who you're teaching. So I might be getting a little bummed. Because I can't look it up. So I know that you have your 10. Okay, I know Mr. J.O. teaches a class right now. But this is the math. There could be other math teachers. So you're here right now. Go all the way down this hallway. Turn right. Without knowing who your teacher is. I'm going to move people around in a minute. Just sit wherever. Oh, you mean the right class? Yes, I believe so. I believe you are in the right teaching here. Yes, you are.